Today, we are going to look at the mean value theorem for integrals and second fundamental theorem of calculus, as well as average value for function in this video. So let's begin with the mean value theorem for integrals. The theorem says, if my function f is continuous on a closed interval a to b, then there exists a number c in this closed interval such that a to b fx dx equals f at c times b minus a. What this basic theorem in a nutshell talks about is this. So here we have a continuous function from the interval a to b. And the mean value theorem says that somewhere between the circumscribed and the inscribed circle. Do you see that here? Rectangle, not circle. So the circumscribed and an inscribed rectangle, there is a value c whose area is exactly the same as the area of the region under the curve. Okay, so that is the real meaning of your mean value theorem. The only thing you have to do is make sure that the function you are looking at is continuous in the closed interval. If it is not continuous, we cannot apply this theorem. Let's look at an example. It says find the value of c, which is guaranteed by the mean value theorem for integrals for the function over the given interval. Okay, now clearly let's look at the cosine function. Before I can apply the mean value theorem, I have to make sure that the function is continuous in this closed interval. We all know cosine function is continuous throughout the real line, so we have no problems. Clearly, f is continuous on the closed interval minus pi by 3 to pi by 3. Thus, by the mean value theorem for integrals, the function minus pi thirds 2 pi thirds of cosine x dx equals f of c times b minus a. Now remember, this is your a, this is your b. Pi thirds minus of minus pi thirds. Okay, if you remember, cosine integral is sine. So this side, the left-hand side of the equal sign, is a fundamental theorem of calculus. Okay, so this one is sine x minus pi thirds 2 pi thirds. Now this one is 2 pi thirds. Pi thirds minus of minus pi thirds is 2 pi thirds. So we have here 2 pi thirds f of c. What is f of c? Cosine c. Okay. Now we are going to apply here on the left hand side. I'm going to make my life simple because I want to do this work. So I'm going to take this on this side. I'm going to write this as 2 pi thirds cosine c equals sine x minus pi thirds 2 pi thirds. Now all is simple algebra and little trick used over here. Okay, so what's 2 pi thirds? Just let it be like this. Don't do anything at this point. Now you're going to put sine of pi thirds minus of sine of minus pi thirds. Now remember that sine is an odd function. So using that, this right-hand side becomes sine pi third plus sine pi third, which is now 2 sine pi thirds on the right-hand side of the equal sign. The left-hand side is what? 2 pi thirds cosine C. Now the 2's and the 2's get cancelled. What do we have? Cosine C, okay, equals 3 over pi sine pi thirds. Now if you guys remember, sine pi thirds is what? Is square root 3 over 2. Remember, sine pi thirds is sine 60, which is square root 3 over 2. Now here, you are just going to use your calculators, and this will now be C equals cosine inverse 3 root 3 over 2 pi, and your C will be an approximatory 2 answers plus minus 0.5971. Okay. So that's how you apply the mean value theorem for integrals. I have given one for you guys to practice. So I would like you guys to practice this problem. Okay, now let's go ahead and do the average value of a function. That's the next theorem. Now, average value theorem is basically taken from the mean value theorem. Here, the value of f of c, which was given in the mean value theorem, is actually called the average value of the function on the interval f of a to b. So what is this average value of a function saying? It says if your function is integrable on a closed interval, then the average value of that function f on that same interval a to b is given by this formula 1 over b minus a integral a to b fx dx is f of c. So what we notice is that the average value of the function in a simple way is this. This is how you look at it. So the area of the region under the graph of the function, so this under this graph, this area, guys, we're talking about, it is equal to the area of the rectangle whose height is the average value as shown below. Just focus on the formula. Okay, the average value, remember, is f of c. Okay. So just the average value, which we basically call f of c. So you just remember this formula. Okay. That's what this formula is talking about. Now it says find the average value of a function over the given interval and all the values of x in this interval for which this function equals its average value. So if you remember, this function is clearly integrable. Remember that, function has to be integrable. Nice little polynomial, and this is a nice little integrable function over this interval -1 to 2. So we're going to say is, my function f is integrable. And hence we can apply the average, find the average value of the function. So the average value of this function f is given by 1 over b minus a integral -1 to 2 fx dx. Okay, b, guys, is 2 and a is -1. So it is 1 over 2 minus of -1 integral -1 to 2 4x cubed minus 3x squared dx. Now after this is simple integral stuff, guys. Okay, what's this? It is 1/3. Do the indefinite integral. So this comes to be x to the 4th minus x cubed from -1 to 2. And when you do the math over here, and remember this is average value of this, so this is f of c. Remember that, guys, okay? F of c. So I'm going to write this one, f of c equals 1/3 x4 minus x cubed 1 minus 1 to 2. Now what is f of c, guys? It's 4c cubed minus 3c squared, and 1/3, when you plug this one, is 2 to the 4 minus 2 cubed. Remember, you're applying the first fundamental theorem of calculus, minus of, keep this thing in mind, this, guys, is capital F of x. And what I'm doing is, I'm doing f of 2 minus f of minus 1. So this is f of 2. Now minus f of minus 1 is minus 1 to the 4 minus of minus 1 cubed. So when you do the math over here, guys, it's 1/3. You will get 8 minus 2, which is 6/3, which is basically a 2. So what you're getting, 4c cubed minus 3c squared. Or basically you want to find the c, which will make that average value happen. So 4c cubed minus 3c squared minus 2 equals 0. So basically you want to find the c, which will satisfy this equation. So using your calculators and the 0 of the function, you find that c is approximately 1.1368. Okay? Now, so just basically you have to apply the formula, and then you have to just do integrals and first fundamental theorem of calculus. Okay, so this, guys, is a practice for you. Make sure you practice this. Apply the average value for function formula. Now the last thing we're going to do in this section is the second fundamental theorem of calculus. Before I introduce to you the second fundamental, let me talk about certain things here. Now the definite integral, when we were doing of the function on an interval, it was defined using the constant b as the upper limit and upper limit of integration and x as the variable of integration. In other words, the definite integral a to b fx dx. A and b, guys, were constants and x was the variable of integral. But there might be scenarios where one of the variables, one of the limits is not a constant. It is a variable. For example, you might have a scenario where you have a to x and f, remember now the variable of integral is say t. So instead of having a constant as the upper limit, you have a variable as an upper limit. So normally when we have variables as part of the limits of the integral, we change the variable of the function which is given so that there's less confusion. Okay? So this is the definite integral. When you solve these problems where your a and b are constants, the definite integral will give us a number. On the other hand, when we have one of the limits to be a variable, then this definite integral is a function of x. So here is the nicer way of looking at it. So here's it, a constant. So the definite integral is a number and f is a function of x. Where this definite integral is a function of x, where this means one of the limits is a function of x. So the inside the integrand now becomes a variable of t. So what does the second fundamental theorem of calculus says? The second fundamental theorem of calculus says, if a function f is continuous on an open interval I, which contains an a, Then for every x in that interval, the differential of the integral from a to x f of t dt is nothing but you go to the original integrand, f, the little f, and replace the t by an x. That's it. Okay? So in other words, remember, if this would be, if you look at this one, so it's a differential. Remember, this integral is an antiderivative, which we represented as f of x. That's what it means. So in other words, the capital F prime of x is little f of x. Let me write it this little nicely. Okay. Now, we're actually going to do first by hand, literally apply the integrals and then see if the second fundamental theorem of calculus works. Okay, so here's the example on it. We are going to first integrate this integral and find this fx. Here what is happening is your a is a constant, whereas the upper limit is a variable. So the question says integrate this integral to find the capital F as a function of x. And then we demonstrate the second fundamental, that is, you take the derivative, which will be equal to f of x. Okay, let's first of all integrate this function given to us. In other words, this part. Okay, so let's look at this. 0 to x t square plus 1 dt. Before I apply the first fundamental, I'm just going to make my life simpler and write this as 0 to x t cubed plus t dt. Then do the indefinite integral inside and then do the apply the first fundamental. So this is going to be t 4 over 4 plus t square over 2. You're going from 0 to x. Now remember, this is the antiderivative f of t. So when you solve it here, what do you get? F of x minus f of 0. Wherever there's a t, replace it by x. So it's going to be x to the 4 over 4 plus x squared over 2. And when you replace this by 0, it's simply a 0 over 4 plus a 0 over 2. So what are we getting? We're getting x to the 4 over 4 plus x squared over 2. Okay, that is my capital F of x. Now, we have to now prove the second part of this question, demonstrate the second fundamental theorem of calculus. Okay. So this is our f of x. Do you see that here? This is our f of x. So what you're going to do is, we're going to take the derivative of f prime of x, the first derivative. So notice my f of x is x4 over 4 plus x squared over 2. I'm going to show the second fundamental theorem of calculus, which is f prime of x, which is going to be what? 4x cubed over 4 plus 2x squared over 2, which is x cubed plus x. Sorry. Now, I can write this as x times x squared plus 1. Notice this is exactly what this is. If I take the second differential, this will replace this, which is what we have. Okay. Now, so how the problems will be given to you. This is how a problem will be given to you. Let's look at this last example. It says, use the fundamental theorem of calculus to find capital F prime of x. Now remember, the second fundamental theorem says the capital F prime of x is nothing but little f of x. So in other words, this is your f of t. Replace wherever there's a t by an x. So by second fundamental theorem of calculus, it is x squared over 1 over x squared. That's it. You just have to remember what is the small f and what is the capital F. That's what you have to do in this problem. As usual, I always give you some problems to solve. So guys, make sure you are practicing these problems which I have given to you. Thank you.